Let us talk about Git. So, what is a Git repository? It is a source code management tool. What is mean by source code? Source code is nothing but the plain text code written by the developers who build the software, right? So, each and every software your company owns, it is nothing but set of code written by your developers. But the software does not contain this code in it. I mean, they were developed from the code, then this code is converted into some machine understandable form and everything. But yeah, it's all begin from a source code, right? That's where everything begins. So we had discussed in our demo class. I don't know if you still remember that already. We discussed in the demo class that the DevOps is there in the picture because today's software are pretty complex and people need modification to the software very frequently. Each time whenever you want to make some change in the softwares, right? You have a software product and you should keep on making changes to the software product if you want this product to be successful in the market. Maybe keep on adding more features, keep on fixing some bugs that it already have. So like that, all these changes would need some developers to make some code modification, and once they made the code modification, they will check that into a source code management tool. So assume Git is more like a repository, and there are lot of change, lot of developers working for different issues. Maybe this is a cab application that your company is developing, and there are some changes required for the cab application. This is Tom. He want to make some change in the source code. He has the source code in his computer. He make the changes in the source code, and once he's done, he will update his change into a central repository. Let's call it Git. And same pattern would repeat by every developer. Whenever they make any code change, they keep on updating their code change into a source code management tool. Git is an example for a source code management tool. So each time a developer make change in the source code, Git will track all those changes. Let's say Tom made some code modification, he added some class, he created some little bit of cosmetic modifications and everything to the software. And once he made his code changes, he update the code change into the Git repository by doing a commit operation. And when Tom does that, Git will record the work done by Tom. Git will just note down the current time when this change was made, who made this change, at what time this change was made, which files are modified, did the developer added any command, and which exact lines of code were modified, which lines are removed, which lines are added up. So everything about the change done by developers are saved in the source code management tool, right? And this source code management tool contains the work done by every developer, not just one. So what it means is whatever change that you make, it is contained in the repository. So assume this, your software development started something like a year back or maybe 2 year back. You have been somebody saying unable to hear. Can you hear me? Am I audible?
Yes.
Okay. So think about a software which software development started maybe 2 year back. Ever since, these developers keep on making commits. They keep on making commits to this repository, and all the commits which the developers are making are being recorded in this particular repository. It is more like the entire software change history is being recorded inside your Git repository. Think about that, right? It would be very helpful at any point of time. You can ask this Git repository in 2014 December, what are the changes that have been taken place? Who made this particular code change? So all everything, right? All this information you want to know about the history of your software development, you can ask your SCM tool, source code management tool, for example Git. Git can answer you with whatever answer that you're looking for, because it knows the entire details about your previous changes in the software, maybe ever since the software development has started. So that's what a Git repository is, and this is not just the only purpose. I mean, whenever multiple developers work together, let's say there are 10 or 15 developers who are working together, they all need a central place where they want to keep their code changes in, right? uh, Tom, Jerry, there are different developers. All of them make code change and they will commit their change into the repository. So at any point of time, developers can download the latest code from this repository also. So there are many features like that. So it would enable the developers to work individually. I mean, whenever somebody want to work on some change, they can get the latest code from the repository, then start working on it. Whenever they are done, they can commit the change back to the repository. So this way, multiple people, if there are 50 or maybe hundreds of people working on the same software, they can work together without having to disturb the others. All of them can make their changes and then they can commit their change to the Git repository. So this way, things would become pretty easy for you. And right now, when we learned Git, we are actually only covering. We are not moving into deployment or any practices. Our purpose is we need to understand Git. What are the different operations that you can perform within Git, and also uh, how it can help achieve this continuous integration is also something that we will discuss. Okay, so first thing, I will tell you how exactly the developer make the change. So I told you each time a developer make a change, the change are committed to Git. Git will record such changes. Whatever commit developers are making, Git will record those commits. Okay. So first I will talk about okay and yeah. So think about this. This is a Google company. They are developing the Android operating system, and there are multiple developers in Google working on the Android operating system. They keep on making commits. They keep on making changes to the software. The change will happen continuously inside the software, and at some point they would decide that okay, let's release a new version of Android, maybe ice cream sandwich. And it does not stop the developers working on Android operating system. They keep to continue working on the Android operating system. They make more changes and everything. At some point of time they would realize that okay, this is time to do a major release. They will then release Jelly Bean. So like that, at specific points of time there would be a single main line, and at that main line you will mark some points where you can mark the changes as a release or a tag, which we will come into. So this is a advantage, right? Multiple people can work together and they can keep on coming, making the changes, and somebody can validate the changes, and maybe when the time is right you can do a release to the market. Your software change should be released to the market. Okay, so we will see how exactly the workflow of Git will look like, right? So consider this is a developer laptop. This is Tom and this is Jerry, right? There are multiple developers. So where does this Git repository exist? I told you every developer would commit their change into a Git repository. Where does this Git repository exist? Any guess? Actually, a local repository will exist inside every developer's laptop. This is what the Git repository is, and that exists in individual developers' laptop. Make a note. Each and every laptop themselves are repositories to which whenever developer makes some change, they will do the commits. So this is Tom's laptop. He will install Git inside Tom's laptop and he will set up a local repository, and he will have the software code, the source code I am talking about. He will have the source code, I am going to call it the working copy, which is typically saved inside some folder in your machine, right? In the developer's laptop under some folder. He might have kept the the software code, the source code. So that's what the working copy is, the actual source code. And developers, what they are supposed to do, they are supposed to make changes in the software code. So they need to modify these files. Maybe they need to add some new classes. They need to add some new libraries. They want to do some code modification. Anyway, you are not bothered at all about the coding part. But of course, you know that there is a code, source code, which developers will modify whenever they want to make some change to the software. That's how they change the software, right? They need to make modification in the source code. All right, so you have a working copy in every developer's laptop, and there would be a staging area or a staging repository. So what are they? It is the local repository that get commits. I told you, Git will record each and every commit made by individual developers. Tom made a commit, Git will remember that. Jerry make a commit, Git will remember that too. So whatever commits are being taken care, are being ran, Git will record everything. That's what Git will do. So where does this change are being taken place? Actually into the local repository of individual developer's laptop. Tom is making a commit. He is making the commit to his local repository inside his laptop. When Jerry want to make some change, Jerry will also have the working copy. He make the code changes here. Then once he made the code changes, maybe there are 100 files inside this working copy. He modified only one or two files. Whichever files he modified, first he will perform a add operation. That's what everyone will do. Even Tom would do the same thing. First he will perform an add operation to whichever modification Tom want to be part of the repository, or whatever modification Tom decided that to be stable, he will first add those files into the staging area. Then he will make a commit operation, which will basically whichever files that you put inside the staging area will be committed to the local repository of Tom. Great. And Jerry does the same thing whenever he want to work on something. He also have the working copy with him. He make the code changes and he will perform an add operation to add whichever file that he modified into a staging area. And when he is satisfied, when he is ready, he will do a commit operation to update the change to the local repository. So it is this commit operation the Git repository will record. The local repository is nothing but a Git repository. Okay, fine. So Tom made some change, Jerry made some change. Tom's change is available in the local repository of Tom, that means inside Tom's laptop. Jerry's changes are available only in the Jerry's laptop. Does that give you the solution that you're looking for? No. Basically, if there is a third developer, of course he want the latest code. He want the latest code from Tom. He want the latest code from Jerry. Whichever developer made modification, he want the latest. So there must be a remote repository that you keep, which is actually same as this local repository. Not much differences. The thing is that each time a developer make a commit, they will synchronize their local repository with the remote repository. Synchronizing operation means whichever commits are there in the local repository, but they are not there in the remote repository, those commits would be copied to the remote repository. Same way here also. Jerry will also do the same thing. When he make a commit, he will perform a push operation. That's what both Tom and Jerry will do. They will perform a push operation to update their changes into a remote repository. Now the remote repository will contain the commit done by Jerry and the commit done by Tom. So it will contain all commits. And a third developer can get the latest code always from the remote repository that will contains all the changes which developers have pushed so far. This is how the common workflow of Git will look like. Got it? Always remember the local repository is saved in individual laptops. Commit operations are performed in individual laptops. Later, they are uploaded to the remote repository. That means in a central place by performing a push operation, which we will talk about. Okay, great. So,
Basil,
yeah.
I have a quick question. See, for the developers, no, they'll come for the, they'll say that they've commit the code,
Mhm,
okay?
mhm.
Then they'll ask us to push the code to live. So is it like, uh, so we should do that pushing, or, what is that?
They
Developer will
would
do
be
that.
the ones typically doing the push whatever change they had made. They need to do the push operation to make sure that the change is available in the repository. So pushing to the live, doing the release process, we will talk about it at the end of Git classes. Yeah,
All right. Yeah.
right. Of course, I mean it is the developer. Unless they pushed their change, it is not available to a second person. As long as they keep their commits in their laptop local repository, then that is not visible by others. It need to be copied into a central place. That's why you are doing the push operation.
Hmm. Okay.
Yeah.
So from that Git repo, that remote repository to live servers, right?
Uh,
That is a different
Not
case. Oh.
directly. Yes, yes. Basically, that's what we need to do. Whatever change. Before that, you need to do a lot of things. You need to validate the changes, make sure that the changes
Hmm.
are stable, do some testing, right? There are a lot of things that
Hmm.
you need to do. But yes, it is the same code or maybe a modified code. Due to some bugs, you have to modify something. So it is the same code in the Git repository that you want to deploy into the live or production environment. That's correct.
Okay.
So we will talk about that process later. Yeah. All right. So you understood what is a local repository, what is a working directory and staging area. Blobs or trees are nothing but actually inside the Git repository, inside the local repository or inside the Git repository. If you look at that repository, you will not see the files and folders. Instead, it would be a lot of binary files, right? Make a note. You make some change, you update the changes into the Git repository. Git does not save the entire file, but only the modifications. You have a 1,000 lines file. You modified one line and added a new entry there. Git will, when you do the commit, Git will record only that small change, not the entire file. Make a note. So this is possible because the Git save the changes. Only changes would be saved by Git, and those changes are saved in a binary form. So the files inside Git are called blobs, and the folders inside Git are called trees. Internally, this is how they are referred. You won't find any folder or file inside a repository. If you explore it, all you see is a number of binary files. So blobs refer to the files, and trees refer to the folders. Commits, I already discussed what is meant by a commit, and we have seen what is a pull operation or push operation. So what is push and what is pull? Push, I already told you, whenever developer makes some change. This is Tom's laptop. This is Jerry's laptop. This is the remote repository, the central repository. Tom makes some change. He will update the change in his local repository first. Then he will do a push operation to update the change to the remote repository. Now this is Jerry. Can Jerry see the change done by Tom? No, because Jerry still has the old working copy with him, which does not have the change done by Tom. What will Jerry do? He can perform a pull operation. When he perform a pull operation, whatever new commits are available in the remote repository and which are not available in the local repository, that will be copied to Jerry's local repository automatically. So that is also pull is just reverse to push operation. And add operation, you understood. This is a developer laptop. It will have a working copy. First, you have to perform an add operation. Let's say you modified a number of files inside your working copy. First, you need to add the files, then only you can commit it. So first add the file into a staging area. That's what you call add operation. Then you make a commit. The commit will go to the local repository, right? So this is the how exactly they work. Okay, clone is something like, let's think about this. There is a remote repository, and there is Tom who is already working on the project. This is Jerry who is already working on the project, and there is a new guy who want to join the project. He does not have his local repository. He does not have the staging area. He does not have the working copy. Nothing is there in his laptop. What he can do, he can perform a clone operation from the remote repository. Basically, it will copy this entire remote repository to the local repository of the new developer. It's something you can do. So automatically, whatever commits that happened so far would also be copied into the individual developer's laptop. Okay, so that's what a clone operation is. Yeah, do one thing, take a short break of 5 minutes, and we will continue in 5 minutes.
Uh, I Anyone there? Is the class going on?
Yes, yes, yes.
Hey, welcome back. So, so now you know what is a local repository, what is a working copy and a staging area, blobs, trees, commits, branches and tag we will talk about, clone, pull, push operations. Head is a pointer that points to the latest revision, latest commit ID. So each time a commit is made to Git, this is your Git repository to which many developer make commits. So all these commits into this Git repository will get a unique ID. It is called commit ID. It will contain for all these commits will have a unique ID, and head is a pointer which will always point to the latest commit ID. Right? Whatever is the latest commit, head would is a pointer which points to the latest commit ID. Revision is nothing but each commits that you make would form a new revision of the code. URL, okay, I will talk about what is URL. I told you you would keep one remote repository and n number of laptops connecting to it. There is one remote repository. To this remote repository, all developer would do the push and pull operations, push, pull, or clone whatever operation. Individual developers would commit to the repository, push or pull, whatever. So, so when this laptop connect to the remote repository, how they will connect? Actually, these are developers' laptops, and typically the remote repository is nothing but a remote server, maybe running Ubuntu operating system or whatever, where you set up the Git repository. So this is typically a remote machine to which the developers will connect through a network, and they will connect through some URL, and it can be either SSH connection or it can be HTTP connection. Using one of these connection, the developer's machine will connect to the remote repository using a URL. The URL will contain the, if it is a SSH connection, it will contain the SSH username, maybe Git or maybe Ubuntu, the Linux user, at the rate, the IP address of the machine, the remote repository, colon, the name of the project. Inside the remote repository, you will create a repository, the name of that particular repository. So these things containing these three things, under which user this remote repository is running, what is the IP address of this machine, and what is the project name. So putting all this information together, you would create a URL, and this URL every developer would use to connect with the remote machine, right? Every developer would connect to that URL whenever they want to do a push, pull, or clone operations. That's what a URL is. The URL has this particular syntax which is used by the developers when they want to connect with the remote machine. Yes, Balraj. So that's what a URL is. And now let's say I'll talk about what is a branch and what is a tag. I already told you. Assume this is the main line inside Git. I call it main line, and generally this is a branch called master. I will come to that. So assume whatever change developers make, they do the commit into the master branch. So within a repository, you can actually create multiple branches. By default, master is the default branch where you are doing these commits. Developer keep on making commits, and let's say at one point of time, Tom got another work. Tom got a different work saying that he need to integrate Paytm payment option into the cab application, which he believe it's a complex work and it will take a lot of time to complete. He need to make modification to a lot of files and make a lot of modifications. So what he does is he does not want to make the changes in all the file and then make a final commit. It will take a lot of time. Instead of that, what Tom does is he will get the latest code from here, whatever all the commits are there in the Git repository. From that point, he will take the full Git repository, the latest code he will take. Then he will create a new branch from there. Starting from there, he will create a new branch. Maybe he will name the branch something like, let's say, Paytm. So now Tom can start working on this branch. Instead of master, he can make his commits. He is making a lot of modification regarding Paytm. He make whenever he makes some change, he will keep on committing those change to the Paytm branch instead of master branch. It's a better idea because there is no confusion. And when you are done, when Tom is finished with his change, he believe that he has done enough commit and he is done. He is done with integrating the Paytm payment option into the application. Then he will merge this code with the master, the latest code that you have in the Paytm branch. It would be merged with the master. What it means is uh, now the master branch will contain whatever change Tom had done so far in the separate repository. And also there would be some other developer who keep on making committing to the master branch, right? They don't need to be stopped. They can continue and make change into the master branch. It is only Tom who created a new branch and he is working on that branch, which is absolutely fine. At any point of time, you can then merge the branch back to the master, and then it will move on like a single branch. Also, the tags are nothing but we discussed, right? Let's say you a developer keep on doing some change, and at some point of time they realize that okay, it is time to do a release. You have the latest code, which is a stable code, which is tested fine. It is time to do a release. Then you can tag this as maybe 1.0. So like that, at some point of your development mainline, you would mark some point. Basically, these are typically the software releases or some tags or some patches, right? So you can actually mark inside a Git repository which which points are important. That's what a tag is, right? So that's pretty much about the tag, branch, and tag. So we are going to talk about it in detail when we move into the training. So yeah. So what I am going to do is I'm going to create my EC2 machine and I am going to set up Git inside it. So go ahead and create a new machine. Okay, so I'm going to log into the machine. Okay, so we have been discussing about Tom's laptop. Then we have discussed about Jerry's laptop. Then we discussed about the remote repository. So assume we need at least three machines for our testing. One machine which will be used as remote repository, other two machines which would be used as individual laptops. But in my case, I have only one EC2 machine that I have created inside AWS. I created a Linux machine, but I have only one machine. What I am going to do now is I will create separate users. I will create a user called Tom, and under Tom user I will set up Tom's local repositories and everything. I will create another user called Jerry. Under Jerry user I will set up Jerry's environments and everything. Then I will create one more user called Git. Inside that user I will set up the remote repository. So technically there are actually three machines, but I am going to run it all in a single machine, right? But we are following the approach, and the steps that we are following are for the remote machines. Even though they are on the same EC2 machine, they will try to connect through a network, which we will see, right? So I don't want to create three EC2 machine. That's the reason I am creating only one machine, and I am creating three users inside that machine by running the user add command. User add Tom, user add Jerry, user add Git. I created three users, setting password for them. Okay, I set password for all the users. Great. So first thing first, what I'm going to do is I'm going to create the remote repository. First, I will install Git. This is the command in Ubuntu, you need to run this command to install Git. apt-get install git core, which would actually install Git core. It is installed, perfect. Now it is time to configure your Git. So first you need to specify your mail ID and password, which is important. So like this, you need to mention your name and email. Then these are some color settings that I am putting in the UI. Should it give some color, or the git status command, will it give color? So we'll come to basically some cosmetic changes is what I am doing right now by running these commands. They are not very important. I am also setting which editor git would use by running this particular command. I am setting vim as the default favorite editor for git. Then also like this I can make change. So run this particular command, you are telling what tool you would use for merge operation. Sometimes multiple files need to be combined together to be merged into a single file. So at that particular time, what is the merge tool with git would internally use is what you mentioned here. So like that, you are configuring git, and finally you want to see the git configuration. You can run this command git config hyphen list, which would show you the username, email, then other settings that you had mentioned. Perfect. So this is how you install Git and configure it. Now it is time to create a remote repository. Right? That's what you want to do. I'm going to create a remote repository in machine. So first I will log in as user Git. I will log in from 3 terminal. In the first terminal, I logged in as user Git. In the second terminal, I am going to log in as user Tom. Let me SSH. Let me log in as Tom. Then in another tab, I am going to log in as Jerry. Okay, so here it's Jerry, here it's Tom, and here it is the Git user. Great. So under the Git user, I'm going to create a project. So this is the Git user. I'm going to create a project. All I do is first I create a folder, and inside the folder I am going to run this command git bear init, which would actually make this folder, the current folder where I am in, this particular folder would become a remote repository or a Git repository actually. But I'm going to use this one as a remote repository. So the remote repository is now ready. Cool. It is ready now. Now it is time to set up the local repository in individual developer's laptop in Tom and Jerry's laptops. So let me log into Tom's laptop. This is Tom's laptop. First, I will create a folder, let's say Tom repo, and go inside that particular folder. This is where I'm going to create my Git repository. The command is git hyphen hyphen init will actually create the, sorry, there is no hyphen hyphen. Simply run the command git init, which would actually create a local repository. Great. So you created a remote repository under the git user. It's under git user you created the remote repository. Then it's under the Tom user you created a local repository in his laptop. Right. So where is my working copy? Where is my staging area? They are yet to come. So what I am going to do right now is I'm going to add some files to my local repository. So I already have created the local repository. It would be created inside a hidden folder.git. That's fine. You don't really need to worry about what is inside .git. They are binaries. No need to focus on it. But yeah, I am right now. I am on Tom's laptop, and what Tom is going to do is Tom want to make some change. So let's say Tom want to create a new file, test.txt, the project code which Tom modified. to fix something, right? So there would be multiple files, right? Don't assume these are plain text file. These are nothing but the source code of the product. So like this, you have another file called readme. So like that, assume you have number of files, and what Tom is now going to do is he is going to add both the file into the Git repository by performing a add operation. Remember, now the working copy is nothing but the current folder of Tom, the Tom repo folder, inside where I created two files. This is the source code test.txt and readme files. And these two files I already modified these files. I already created these files and put some content inside that. Now it is time to add these files into a staging area first. Then it will be committed to the local repository. So first, let me perform an add operation to add these files into the staging area. So git add test.txt to add the test.txt file. Then run the command git add readme to add the readme file. So both files have now been added to the staging area. Now it is time to do a commit operation. How you will do the commit? The command is git commit -m. Then you put something, some message you can put, added to files. Some message. It should be something meaningful. Always try to make the message. Developer would always try to make these messages more meaningful. They would put something like Paytm issue has fixed, the login problem is rectified. So like that, some meaningful comment, what all change they had worked on, a summary about that work they would put in a very small sentence is what a comment in Git is. So when you perform the Git commit operation, always remember the commit is being done on Tom's laptop only, not into the remote repository. Make a note. Unless you perform the push operation, this change will stay inside the local repository of Tom. It won't be visible to anybody else. So it is important that after you made a commit, it is very important that you do the push operation and make this change available to everyone. So that's what I'm going to do. Run this command git commit -m, then specify like this. Okay, over here, right. If you try to perform a commit operation, what does Git will record? Let's say this is you making a commit to a Git repository. Does the Git repository will do? It will record this commit. Who made this commit? At what time the commit was made? So who made this commit is something that you must publish to Git. I mean, Git want to know who you are. If you are doing some commit, Git want to know who you are so that Git can record it. So first I need to introduce myself to Git. Tom need to introduce himself to Git by specifying his email ID and password, email ID and username. The username I am going to put it as Tom. Okay. So now he can do the commit operation. Now he run the same command. It is committed. Perfect. So the commit is done on Tom's laptop. Now you have the working copy. Working copy is nothing but this particular folder Tom repo, inside where I created two files, test.txt and readme. And these files have already been added by doing an add operation. It is available in the staging area. Now you performed a commit operation to add these files into the local repository of Tom. Always remember, this is not the remote repository. Remote repository is somewhere else. So this change need to be pushed to the remote repository. At that point only, whatever commit that you have so far will be copied to the remote repository and it will become available to people. Okay, so -m is the option that you use to put a command. -m, then you can put some command. That's what -m is. Okay, so right, so now it is time to do a push operation. So this is Tom's laptop where we are in right now. and in the local repository now there are commits. This need to be pushed into the remote repository. So you need to perform a push operation. So what do you want? If you want to perform a push operation to a remote machine, you want the URL of the remote machine, the git URL. What is that? Under which user the remote repository is running, under which user it is running, under the git user it is running, at the rate the IP address of the remote machine. In this particular case, you can put localhost because both Tom's user and Git user are actually on the same EC2 machine. So in that case, in this particular case, I can put localhost here, or generally the IP address of the remote repository or the host name of the remote repository is what being used here. Then colon, you need to put the project name, whatever project inside the remote repository. So you already have done that, right? You already have created a folder called project.git, right? And you run the git bear init command. So this is your remote repository. So that name you need to mention in this particular URL. So this is how the URL will look like. What I'm going to do is this URL, I am going to add them into Tom's computer. The command is git add remote origin, then the URL git at the rate localhost colon project dot git. This is the command git remote add, right? Not add remote, it's remote add git remote. So I will tell you what this command exactly means. I'm going to add a remote repository, of course. It's very clear. Add origin. So this is the URL that I am going to add into the Tom's laptop as origin. Basically, where the code need to be pushed is what the origin is. So you are giving a name where the code need to be pushed. Instead of specifying this entire URL, you are giving a name. So run this particular command, and that's it. You already added the remote git repository. Now it is time to do a push operation. Now it is time to do a push operation. Can I do the push operation? Will it work? This is Tom's laptop. I already have the local repository which has a commit, and then I have the remote repository. Now I want to perform a push operation. So when I perform this push operation, what will happen? Whatever commits are there in the local repository will be copied to the remote repository, of course. But how does the push operation work? Basically, Tom's laptop will connect to the remote repository through SSH. That's how it works. So if you want the SSH authentication to work, the user Tom should be able to connect to the remote repository through SSH using key authentication is what we would prefer to do, key authentication. So first, what I'm going to do is inside Tom's laptop, I will create a key pair, a private public key pair. This public key I will then copy into the Git user. It is under the Git user, the remote repository is running. Into that Git user, I will copy this public key. That's what I'm going to do. So let us go ahead and run it. So run this command git ssh keygen is the command I'm going to run inside Tom's laptop, which created a private. This is the private key. This is the public key. The public key I'm going to copy into the remote repository. So this is the remote repository under Git user. Under Git user, you type ls-l. There is no folder called .sh. I will create a folder called .ssh. Go inside .sh folder, create a new file called authorized keys. And inside this authorized keys, I'm going to paste this. That's it. So that's it. You are done. And now it is time for you to, do the push operation from Tom's computer. That's what I'm going to do. The syntax is going to be git push. Then you need to mention where you want to push. Origin. You already added the origin as this particular URL. So to this origin you want to push, to which branch you want to push also you want to mention. By default it is always master branch. We will talk about the branches, how we can create multiple branches. By default, if you don't create one, there would be one branch called master to which you are committing all the changes by default. So I'm mentioning what is the branch name where I am doing this pushing. So basically, what does that mean? Right now, I am running this command inside Tom's laptop. This is Tom's laptop, which has a local repository, and there is a remote repository to which I am doing this push operation. So when I do this particular push operation, what would happen? This commit in the local repository is going to be copied into the remote repository through SSH. So master I am mentioning here, basically I am actually mentioning this is a Git repository. This is also a Git repository. Local, remote, forget it. These are nothing but Git repositories. So when this new commit in the local repository get copied to the remote repository, to which branch it is getting copied is what you mentioned here. So this master inside the remote repository is where you want to copy this code. So run this particular command, git push origin master. They will ask, are you sure want to connect? Yes. That's it. It's pushed. The changes are now updated. So now the remote repository got the change done by Tom. Okay. So that's pretty much I wanted to discuss today.
So, Basil,
Any question? Any
can I
question?
ask you?
Yeah, go ahead, Muzammil.
Yeah. Today you started the grid project, right? Grid topic, right?
Git.
Git, sorry, Git, not grid, Git topic.
Yeah, right.
Right, right. And we basically we today used to see the how the commands like push changes to repository. Right now you have finished, and a remote repository and local repositories, what are their functions, what they do when we apply the git command to a remote repository and tom command to local repository. Am I right?
Right.
Right, these are all the functions we are applying to that, right?
Right. Basically, how a developer would work is what we are really focusing on right now.
How the developer will work, right?
Correct.
Right, right. Thank you, sir.
Yeah.
Are we over?
Uh,
Yeah, we are done.
Basil, just a quick question.
Yes, correct.
I mean, let's say if can I go ahead?
Yes.
So, I mean, let's say if I need to make some changes in the WordPress config file, then do I need to get it to Git folder and then do the changes and then place it back, or is there any
Exactly.
other way?
That's the best way. Basically, what you do a pull operation to make sure that you have the latest code from the remote repository. Then make your change.
Okay.
Then commit the change back. Commit it and push it.
Okay. I mean, in order to commit and push it, we need to have that file in the Git
Right.
folder.
Correct.
Okay. Files. I mean, yeah.
Otherwise, if you want to add a new file, how you can do that? Git add command. Simply you have a new file that you want to add to the Git
Okay.
repository. Simply run the git add command. That will do.
Okay. But existing file, can we just copy from the location to this location and just do it, or do we need to have any command?
Git add, yeah, you can simply copy the files into your working copy, then run
Yeah.
the command git add
Okay.
space file name.
Okay. Okay.
Basil,
Yes, Harsha. Yes, Harsha.
Basil, this is Harsha. Yeah, consider two or more developers working on the same source code.
Mhm.
If one developer make the changes in the source code, means he deleted lines of code, and other developer is working on the same source code. What it will be? How it will be recorded?
Uh, it would be, it will result in a conflict. Basically, Git will monitor that also. Let's say one developer deleted a
Okay.
file while the other developer was working on the file, and the developer who
Yeah.
deleted the file first made his error, and the developer who modified the file when he tried to make a commit, it would say the file does not exist, or it would, whenever it finds a conflict, it would throw the error. Or when two developer work on the same file at the same time, let's say one developer pushed it first,
Yeah.
the other developer, he also tries to push, then Git will automatically detect that there's a conflict and it will throw an error. So this other developer need to fix the problem before he can do the push operation. So the conflict will be automatically detected and stopped by Git repository.
See, my question was about the lines of code. Consider the lines of code which is implemented, actually deployed.
Right.
Two developers are working on the same code.
We will come
One
to that.
developer,
Uh,
uh,
I got your question.
yeah,
We have the option to
yeah,
merge the changes, which we will come into.
okay, okay. Thank you.
Yeah, that we will discuss tomorrow. Tomorrow we are discussing that. Yeah, I will check. I don't know
One
which
more thing,
videos are missing, guys. I will make sure that it is uploaded. And 22nd video is uploaded, I believe. Uh,
yeah, it is not uploaded.
20 and 21st is what you wanted, right? Not 20. Sorry. Yeah, I got it.
22nd,
Which one you don't see? 22nd,
23rd also.
23rd also.
22nd.
20.
It is
Yeah, give me today. I will fix that. I mean, I don't. There are lots of confusion in the videos. Correct it.
actually 23rd. There was no class on 23rd.
Yeah, I believe so. You're correct.
Yeah, we had class on 22nd.
That's what I thought.